All right, students, today we are going to take notes over how to do proofs for lesson 4.2. I have two examples to go over, and when you start this, what you want to do is you want to write down the given statements, you want to write down the prove statement, and you want to draw the diagram. Remember, when you're making your T-chart, that you need to label the left-hand side statements and the right-hand side reasons, and that all of the statements have to be numbered and the reasons have to be numbered to match the statements. Okay, so to begin, I'm going to use colors to highlight the givens as we go. So first, what I'd like to do is highlight AC bisects BD, the statement up here, in yellow, and AC bisects BD. When AC bisects BD, what that means is it cuts it in half. So I have two equal pieces. So I'm going to use a single hash mark to show you that this segment here is congruent to this segment here. So let's get started by putting the very first given statement into my T-chart. Number one statement, AC bisects BD. The reason I get to put it in my T-chart is because it is given. Okay, then AC bisects BD, well, what that does is it produces two congruent segments. And so here, DC is congruent to BC. Now, the definition states that when this bisects this, that it intersects at the midpoint, but what we have decided this year is that you're able to go from this step to this step using the definition. So we're going to say that the definition of this would be a segment bisector because we're cutting the segment in half. And so here, this shouldn't be bisector, it should be segment bisector. Okay, then that's all I can do with this information that I have in this picture. So I go back to my given and I say, all right, well, what's the next step? So in orange, I'm going to highlight the next statement here. It says AC bisects this angle. Well, the angle is DAB, and when it bisects an angle, it cuts the angle in half. So it creates two congruent angles. Okay, so I'm going to write the orange statement here. Here it is, AC bisects this angle. I get to put this in my T-chart because it is given. And the actual definition for an angle bisector is that it cuts it in or divides it into two congruent angles. So right here, this is not definition of bisector, it's definition of angle bisector. Okay. All right, next. That's all I can do with this information, so I go and I look for something else. So in blue, I'm going to mark, it says measure of angle ACB. ACB is 90 degrees. We mark 90 degrees with a right angle mark, like so. I get to put this given statement in my T-chart because it was one of the given statements. All right, well, that doesn't really tell me much, but what does this being 90 degrees tell me about this angle? Well, it tells me that it's a right angle, so I write that down. I now know that ACB is a right angle, and the reason I know that is the definition of right angles. Okay, that's all the information that I have for that. So I take a look and I say, well, That's a right angle. And when I have two segments or two lines that intersect to form a right angle, I know that these lines are perpendicular. So next, from this information that I have here, I can then say that AC is perpendicular to BD by definition of perpendicular lines. And in my chart, to show that these are perpendicular, I use the same symbol. It's the right angle mark. Okay, now, if I was just starting here and I knew that this was perpendicular to the base, AC perpendicular to DB, then I'd say it, by definition, it forms a right angle. So now I can say that angle DCA is a right angle. And so with my purple pencil, I'm going to say, right here, this is in purple, that is a right angle. And I get to say that because, again, definition of perpendicular lines. Remember, definitions go both ways. Okay, so now I have this one being a right angle and this one being a right angle. And there is a theorem that states that all right angles are congruent. So therefore, I can say that these two angles are congruent, and that theorem is called the right angles congruence theorem. So now I've got these two angles being congruent. Okay, so I have a lot of pieces congruent now, but look where I'm headed. I'm trying to make sure that this triangle over here on the left equals this triangle over here on the right. In order to do that, the definition says that the definition of congruent triangle says that the corresponding angles have to be congruent and all corresponding sides have to be congruent. And I'm not quite there yet. If you look, right here I have one side, a pair of congruent sides, and then again here I have a pair of congruent angles, one pair of congruent angles, and then here I have two pairs of congruent angles. I need three sides and three angles. So I have a little bit more work to do. So I keep going. All right, so since I can't do anything else with this information, I go back up to the given and I start again. All right, on this one, I'm going to use the red. And the red one says that AD is equal to AB. Okay, so I get to put that in my chart because it is given. Now, remember that when I was talking about the corresponding parts are congruent, that means that these sides have to be congruent, but I don't have them congruent, I have them equal. So I have to change them. When I go from an equal sign to a congruent symbol, like this, that is definition of congruent segments. Okay. All right. So now I have another side. So that's going to be side 2. I need 3 sides and I need 3 angles. So I have still more work to do. Okay, move it up. All right, so I have these 2 angles congruent and I have these 2 angles congruent. There is a theorem that states that the remaining angles are congruent. I can say that the ADC is congruent to ABC because of the third angles theorem. Okay, so now I have this one. I'm going to mark that one in green. So that's 1, 2 here, and then 1, 2, 3. I'm going to mark it with 3 because that's the third angles theorem. These two, those are the right angles are congruent, and then there's those. That was the bisector. Okay, so now I have all my angles. I have angle 1, angle 2, and angle 3. I have side 1, side 2. Now I need side 3. Well, right here, there's your side 3. And side 3 is congruent to itself. 1, 2, 3, because of AC congruent to AC. You should recognize that. That is the reflexive property of congruent segments. And that makes your third set of sides. Okay, so now that you have 3 sets of angles and 3 sets of sides, now you are done, and you can finally say that those two triangles are congruent, and they are congruent because of the definition of congruent triangles. All right, we have one more to do. And what I'd like for you to do is copy down the diagram and the given statements, the proved statements, and draw your T-chart. So write down all your givens, your proof, your diagram. Make your T-chart. Label your T-chart. And remember, for every statement that's numbered, you have to have a matching reason that's also numbered. All right, again, I'm going to use color. So we're going to start with orange. It says B is the midpoint of AD. B is the midpoint of AD, so it's between A and D, and it's cutting it in half. So this segment right here is going to be congruent to this segment right here. Okay, so here I start off by putting B as the midpoint of AD in my T-chart, and I know that it can go on my T-chart because it was given. And I already know where I'm headed. I'm going to say AB is congruent. And notice how I went from A in, so AB. So then I have to say DB. AB congruent to DB. Now, you have to get these letters right. If you look at the name of what you're trying to prove this triangle here is congruent to this triangle. Look at the A, how it's in the center. And the D is in the center. So wherever you see an A, see A is first, then the D has to be first. The B is second, and the B is second. Okay. And I get to write this down because that's the definition of midpoint. All right, next. Next, that's all I can do with that one. So the next one, what I'm going to do is highlight this in green. And I get to put this in my T-chart because it is given. And what that says is that this midpoint cuts this segment in half. So it creates these congruent segments. Therefore, I know that EB is congruent to CB, and that's by definition of midpoint. All right, then I know that the next given is going to be EAB, so this angle right here, I'm going to use an arc mark to mark this one. CDB is this angle right here. So these two are equal they have equal measures according to the given. But remember that when I want to prove that two triangles are congruent, I can't have an equal sign. I have to have those two angles congruent. So I need to rewrite this. I need to change it to be angle EAB congruent to angle CDB. And I get to do that using the definition of, and we need to change this, definition of congruent angles, because these are angles we're talking about. Okay, now that's all I can do there, so I'm going to go up here and use my next given statement. And my next given statement I'm going to highlight in blue. Okay, so AE is equal to DC, so those are equivalent. AE, 1, 2, 3, and DC, 1, 2, 3. Okay, so here, that's given, but remember that when I want to prove triangles congruent, I need congruent statements, not an equal statement or an equation. So I need to change this to be congruent. And in order to do that, that's going to be the definition of congruent. And congruent what? Those are segments, so that's congruent segments. All right. Now, let's stop and take a minute and see what we have. Up here I have a set of sides, so that's sides 1. Here I have another set of sides, so that's sides 2. And here I have another set of congruent sides, so that makes sides 3. So I'm set with my sides because I need 1, 2, and 3. Now I need 3 sets of angles. So I go through my list and I say, oh, well, here's a set of angles. So that's angles 1. But I'm missing 2 sets of angles. So the easiest one to find is this one right here. Those are vertical angles. So I say that EBA is congruent to, and I have to make sure these letters match. If I say E, then B, then A, I have to say C, then B, D. So they have to match. And I get to, those are congruent because of the vertical angles congruence theorem that says all vertical angles are congruent. Then, since this one, I'm going to use 2 marks here and 2 marks here. So then this would be my third set of angles. This is my second set. So my third set is going to be this one here and this one here. So that's AEB, AEB, congruent to DCB. And that's because of the third angles theorem. All right, so now that I have side 1, side 2, and side 3, angle 1, angle 2, and angle 3, now I know that the triangles here are congruent, and they're congruent because of the definition of congruent triangles. All right, folks, that's how you prove Lesson 4.2 proofs. So the proofs that you have will be just like these. And that's it for your helpful hints for proofs.